Okay, second order differential equations, inhomogeneous. So we got our homogeneous equation. It's not equal to 0, but it's equal to an exponential 3e to the power of 5x. So just a note here at the end, when we have an exponential on the right, we're eventually going to let our px just be equal to, now we as usual put an a in front and e, but we'll maintain the 5 there. Okay, so that's what we'll be using in a minute. But we know that the solution to an inhomogeneous equation is u of x plus p of x. So we'll go work out our u of x first. So u of x is just going to be the solution to the homogeneous equation, and we'll write out the characteristic equation of that, minus 16 times k squared minus 16 times k plus 5 equals 0. So use your minus b formula to solve that, or if you wish you can factorize. Before I factorize, what I'm actually going to do is I'm going to multiply everything by minus 1 just to make it easier for me to look at. But if you're doing the minus b formula, it makes no difference. Okay, so I'll break that up into 4k and 4k. And I'll need a 5 and a 1. So let me think there. That'll give me 20, and I'll need to take away. Perfect. Okay. So what I'll get there is 4k is equal to 1, and k is equal to a quarter. Or 4k is equal to minus 5. So k is equal to minus 5 over 4. Now we have our standard solution to the homogeneous second order equation, and that's y. We're going to u of x here, of course. U of x is equal to ae to the power of k1x, so that's a quarter x, plus be to the power of minus 5 over 4x. Okay, now we look at our p of x. So our p of x, so we said we're going to leave it equal to ae to the power of 5x. Alright, so let's go get the derivative of that. And you can do a product rule if you wish, but it's going to be ae to the power of 5x, so the derivative of a turns to 0, so that gets rid of one part of a product rule. But the derivative of e to the power of 5x, or e to the power of 5x, is e to the power of 5x times the derivative of 5x, which is 5. So it's 5a e to the power of 5x. And then getting the second derivative of that, that's going to be 25a e to the power of 5x. Okay, so subbing that back into my original equation. So I've got minus 16 times the second derivative, in which this case is 25a e to the power of 5x, minus 16 times the first derivative, which is 5a e to the power of 5x, plus 5 times the original function, in this case a e to the power of 5x, is equal to the right hand side, which is 3e to the power of 5x. Fantastic. Okay, we're going to tidy up this. So minus 16 by 25 is going to give me minus 400. ae to the power of 5x. Then we have minus 16 by 5 is going to give me minus 80. ae to the power of 5x, and then we've got 5 ae to the power of 5x, and that's all equal to 3e to the power of 5x. And here we can do lots of tidying up, which is great. So minus 400 and plus 5. So oopsie daisy, apologies, I made a mistake there. So minus 400 minus 80 and plus 5, that'll give me minus 475. ae to the power of 5x is equal to 3e to the power of 5x. So I've got my e to the power of 5x, I'll divide both sides by that. So I'm left with minus 475a equals 3. So a equals 3 over minus 475, or minus 3 over 475. So we look back at what our p of x should be. It's ae to the power of 5x. So p of x in this case is equal to 3 over, or minus 1, or minus 475, e to the power of 5x. Okay, so our final solution then is a combination of u of x and p of x. So u of x is ae to the power of 1 quarter, or 0.25x, whichever you prefer, be to the power of minus 5 over 4x. And then plus p of x. So in this case, oopsie daisy, in this case the minus, of course, minus 3 over 475 times e to the power of 5x.